inverting amplifier. So if you have a control voltage change of 100 millivolts and you get out a plate voltage change of 1 volt, that's an amplification factor of U of 10. So
Which would be what?
as far as medium or high, I think I had that.
Well, if it's hard, like from millivolts up to how much do they have to?
It's pretty high. Actually, if you look at, easy way to answer is to look at the third handout, which is from the back of the RCA manual. So the RCA manual had, it was multiple books in one. If you looked at the intro, that's what the first handouts were. That gave you the basics of tubes and how tubes work, and then talked about basic tube characteristics. And then the middle section, which was probably like a half to 2/3 of the total volume of the book, were these kind of breakouts on individual tubes. And it told you parameters for individual tubes. So if you look at the 12AX7, it's a high mu triangle.
Amplification 40, amplification factor, is that new?
Yep, that's it.
40.
40. And then you look at the, let's see, the AZ7 comes next. That's also considered high mu. And that has an amplification factor. Oh,
maybe. Is that right? I don't know if I'm on the right page. 430 usually. Oh, okay, no, it's not.
okay.
430.
Oh, yeah, actually, yeah, these go out of order. All right, you know what, forget that. Look at the 12AY7. Under characteristics.
Well, that's the 40.
Oh, that was the AY7 you were before. Okay, so the AX7, that's interesting. It don't see the
I think it do the AX7. No,
yeah, that's interesting. I don't know why it's not listed.
oh, yeah, so that's a 40 would be like a medium. That's what a medium.
Yeah, I mean, oh, actually it says for characteristics and curves refer to 6AB6. Okay, so that's saying that a 12AX7 is really two 6AB6s.
Okay.
So I don't think I copied the page for the 6AB6. The 6AB6 is something that I wasn't as aware of back when I first made these copies. But if you looked up the 686, then you'll find the application. And I want to say it's like 60.
Yeah.
Because the median is 40, it's like 67. And of course that varies a little from tube to tube, you know. And even within a 12AX7, it varies a little bit from one side to the other. And that's kind of the new thing now that, you know, we've been talking about matched output pairs, we've got matched output pairs for a long time. Well, now the hot thing is matched preamp tube, where the two sides of the tube are matched. And they say they're useful for phase inverters. So the truth is, most phase inverters have feedback built in so that they're properly designed so that they're not that dependent on the tube, right? Because when you're thinking about mass producing a design, you don't want to be dependent on individual variations of devices, right? You want to create the most robust design. So the common phase inverters actually are pretty robust. So it's a bit of hype. All right, the other thing is the plate resistance, and that's simply the resistance between the cathode and plate alternating current. So that's defined as the change in plate voltage versus the change in plate current measured. Okay, so you see, you take a couple of different measurements, and when you relate them different ways, you get different characteristics. So plate voltage to control voltage is mu. Plate voltage to plate current is plate resistance. Transconductance is the combination. It's a ratio of plate current to change in voltage. Okay, so you've probably heard transconductance when you're talking about voltage controlled current sources in circuits. It's GM, right? It's what is the ratio of the change of output current to the change of input voltage. It's a voltage controlled current source. So you specify that. And that's measured in mhos. If mho is. Yeah. So, because it's, you know, it's the inverse. So, The plate efficiency is the ratio of AC power output to the DC plate voltage and DC. Right? So basically the ratio of AC output to DC, right? So obviously you want the highest plate efficiency you can get. All right. Now, one of the things I want to talk about with tubes, that if you play with tubes, you know, tubes burn out, right? They're like a light bulb. It's the easiest analogy you can think of. The heater is almost the exact same thing as a light bulb, only it's designed to give off more electrons and light. So it burns out. The other possibilities, if the vacuum is compromised, air has gotten into the tube, that burns out. They actually burn hotter. They burn red. You can see it. It's very bad.
They don't burn out fast, like.
They will burn.
out really fast.
They will burn out. It depends on how much air has gotten in. Sometimes if it's just a little bit, you can see it. Sometimes if there are other gases present, you see other colors. Sometimes they're blue, you know, depending on what's there. But things happen. They burn out. They lose electrons. Electrons strip. But if they're used lightly, they'll last forever. The most expensive tubes you can find now are new old stock tubes. They're vintage American-made tubes that have been sitting in a warehouse, new in box. The premium dollar. You can also find people, you look on eBay, people sell used old stock tubes, you know, just box of them, because I have boxes of them down in the basement because my grandfather was a television repair technician. So he saved tubes, you know, if he scrapped the TV, he saved the ones that were good. And you can still use it. And so you get RCA, Sylvania, Mullers, all these big name tubes that people want. You can also buy new ones. And they're being manufactured, usually Russia, China, former Yugoslavia. You have different brands. The Electro-Harmonics new sensor tubes, they're made in Russia. Mike Matthews bought a factory in Russia. I forget, Ruby tubes, I think, that come out of China. JJ tubes used to be called Tesla tubes. They come out of, I forget which country, former Yugoslavia. So you can get brand new tubes. And again, they focus on the big ones, 12AX7s and 66s. But now they're coming out with ones that are nominally the odder ones, the 7027s and stuff. Although a lot of times they're using the 6L6 guts in the 7027 and stuff. So they make them compatible, but not necessarily as good as the old American ones. So that's something to be careful of. But what you can do is you can test them. They have tube testers. And it used to be, you know, in my father's era, you could go down to the drugstore and they'd have a tube tester. You could bring your tubes down, you could plug them in and say, oh, this one's bad. So if your TV stops working, you bring your tubes down, you find the one that's bad, and you replace it. And in fact, we did this with my grandmother's old tube television. I still have it. At one point, the screen was getting smaller. And we said, well, okay, that's the vertical deflection tube. So we went down, looked through the box, found a new one, put it back in, boom, the screen was full screen again. You know.
You do some cool visual effects and stuff, manipulating those people.
Yeah, you can probably do something. You can modulate with an LFO like a tremolo.
Yeah.
You can do all kinds of fun stuff. And you look at it, I mean, that's basically an oscilloscope too, right?
Yeah.
You're modulating the control, the scan voltage by an input signal. So, and again, you know, I've got older scopes that are tube-based scopes. And they're kind of cool. They don't work as well. And, they can't read as low voltage, but they've got their own character.
And some of my buddies last year did a TV, a scope TV, one of those old tube,
Okay.
scopes together.
Well, that's a tube CRT. But I actually have ones that are tube CRT and all the amplification is
It's
tube.
too, okay.
Yeah. And you get the certain, I had a couple that I gave away to a friend of Tektronix scopes. You know, Tektronix has those modules?
Mm-hmm.
Well, at some point they transitioned from tube to transistor, so I had ones that were in the transition region where those modules had transistors and tubes in them.
Cool.
And